Hello everyone, I'm Rohit. This is my project done as part of machine learning internship at Indian servers. My project is about credit card fraud detection using CNN in TensorFlow. So let's get started. Coming to the flow of talk, it has four subtopics to be discussed. One is introduction, next problem statement, architecture diagram, and also algorithm. Coming to introduction, fraud can be defined as criminal deception with intent of acquiring financial gain. Credit card fraud can be two types. One is inner card fraud and next is external card fraud. Inner card fraud is done by using false identity. External card fraud is done by using stolen credit card. And also we are going to know about how frauds are recognized. It can be recognized through location, items you buy, frequency, and also amount. And coming to the problem statement. The credit card fraud detection problem includes modelizing past credit card transactions with the knowledge of the ones that turned out to be fraud. This model is then used to identify whether a new transaction is fraudulent or not. In this, we propose a CNN-based fraud detection framework to capture the intrinsic patterns of fraud behaviors learned from labeled data. Credit card fraud detection using neural networks. This involves pattern classification in an unbalanced dataset to determine the fraudulent transactions. And coming to the architecture diagram, here we have historical transactions and also incoming transactions. In historical transactions, we have feature extraction, sampling methods, feature transformation, and also training the CNN model. And coming to the incoming transactions, here we have feature extraction, feature transformation, and also classification. And at last, we have training the CNN model. And classification is subdivided into fraudulent transactions and legitimate transactions. And coming to the algorithm in standard format. The libraries that are imported are Keras, NumPy, etc. The convolution layer is created with convolution 1D and given as input. Max pooling of 1D is used to extract the features. Thank you. Coming to the code. First, I have installed the TensorFlow GPU with this version, and we can check for the updates at tensorflow.org. And then I have imported TensorFlow as TF and Keras from TensorFlow, and sequential model from TensorFlow Keras and flat layers and imported convolution 1D and max pool of 1D. And here we are printing current version of TensorFlow which is already installed in my computer. It should print 2.7.0. Now after we have imported some necessary and supported other libraries. Now let's go ahead and read our CSE using pandas data frame. So we are going to read that into data after running. It will show 5 rows and 31 columns. Coming to the last column, it will show the whether the transaction is fraud or legitimate. Now we'll see the shape of the data. We have 284,807 rows and 31 columns. Now we are going to see the null values present in this data. So we can just say that data is null and sum. So with this we'll get if there is any null values in any column, it says that there is no null values in any column. So we are safe now. Now let's see the another information of this data. It says that all the values are float 64 and the output, which is the target actually, that is in 64, and nothing to worry about it. And we are going to see here how many classes are actually in class, that is 0, 1 and 1 I mean. So we can say here data class value count, so it shows that there are 284,315 transactions were legitimate and just 492 transactions are fraud. So this case of highly imbalanced dataset. So now we have to balance this dataset. So first of all, we are going to get the data frames of non-fraud legitimate actually. In this non-fraud, now we would be getting that is data inside a class which is equals to 0. Similarly, we'll getting the fraud, we are going to see all class equals to 1. With this, we got fraud and non-fraud. Now, let's see the shape of fraud and non-fraud. For fraud data frame, we have got 492 rows, which is actually a fraud, and this is for non-fraud data frame. And those selection now we have to select just 492 rows from this non-fraud data frame, and those selections should be in random. And for random selection, we are going to utilize a sample from a pandas data frame. Non-fraud equals non underscore fraud equals to non underscore fraud dot samples and insert that fraud dot shape and insert the 0. Non-fraud non underscore fraud dot shape, and it is printing 492 rows and 31 columns. That is 492, and also we will get non-fraud with 492 rows. That means it will select a random samples and how many samples we want fraud shape and insert the shape we want 0. That is 492, and also we'll get non-fraud with 492 rows. Now fraud and non-fraud are balanced dataset. Now we have to merge this into two panda data frame together for merging these. For merging this, we can say data equals to fraud.append. Instead that I have appended non-fraud and also I am going to ignore the indexes. Now let's see the data. As you can see, the data contains 984 rows and 31 columns. 984 is nothing but just 2 times of 492. Here we got a balanced dataset, and similarly if you check here at class, inside this fraud transaction is 492 and legitimate transactions is also 492. Future space x dot data and drop a class, and that will drop at axis1, and similarly we have y equals to data, and here we have a class, so we have now x and y. Now we are going to x train equals to transfer x underscore train equals to train underscore test and split inside that x comma y, and also test size we got here we give given equals to 0.2, that is nothing but 20%, and I'm going to stratify this according to y. Now let's check the shape of the xtrain and xtest dataset. So now we have 787 rows for xtrain and 197 for xtest. Now we have to print our training dataset. In training dataset, you see the scaling values is pretty much different. That's why the variance is too much high between this column. So we have to here a standard scaler. So we have to standardize this data. We can do with the bounded scalar. Xtrain equals to scalar dot fit underscore transform inside that x underscore train. And then for x test, we have to pass here scalar, and here we need to pass x test. Why do we do this? Because it avoids overfitting. We are transferring x test on the finding of x train that seems training set. Now we are going to convert by dataset, which is actually by the training and the testing label into a numpy array that read and after one line similarly. So we have here xtrain test and ytrain test to the numpy. We are finally ready to reshape our parameters so we can build our CNN network. Out, it has just two dimension of the data, that is we are going to add here three dimensional. So we have xtrain and we have to reshape 0 is 787. Similarly, xtrain shape, and here we have 1, and then finally 1, and similarly we are going to give for x as, x as well. So the testing and training data set is having the same dimension, nothing to worry about that. Now I am going to convert multi-dimensional data into vector that has done by flattening layer, and next we have dense layer, we have 64 units, we have activation function which is actually ReLU, and we have dropout, we have drop, and we also have dropout. Finally, model.add dense one, and we have activation of function of sigmoid. We are building here actually a binary classification that way we are detecting whether the transaction is fraudulent or it is legitimate. So you should give just single unit that can represent either 1 or 0. Here we got summary of our model. In summary, we got here 119 119,000 parameters. Now we had compared this model, we had passed optimizer, and in that we have passed Adam optimizer, and in with the learning rate of, and then I have passed binary cross entropy loss function, and I have passed metrics accuracy, and we have got the step which is the training our mode. Inside I have passed X data, and the number of approaches which I had defined, that is 50 actually, and I have provided validation data. Model will be also validated on testing dataset, and verbose equals to 1. It will also printing the progress of training. So you can see the approaches. See the training we had got in first step training accuracy 66%, but validation accuracy is 87%. But at the end of the 28 box, we have got validation accuracy of 91.88% and training accuracy is 93.52%. There is some difference between training and valid data accuracy. We can say our model is overfitting. And here I have given def plot learning curve as, and inside that I have given history and epoch. And also we have plot training and validation loss values. If you see here, validation is less than training loss. Moreover, here loss of validation and training dataset is meeting together. Some as something as above also. Some we can neither say our model is overfitting is or not. Either we can say it is underfitting. So I've added here max pool. So if you see here after 20 epoch, accuracy has been 91%, same accuracy for training and testing as well. So if you see after 20 and 30 epoch, the training and the validation accuracy has been saturated. So we say by using convolution. So we say by using convolution neural network, we had achieved 91.37% accuracy by adding pooling without by adding pooling. And without adding pooling layer, we have 91.88%, which is little larger than this. Thank you.